Let me just make sure that's actually live for reals. Yes, it is. Okay, cool. So,
all right, there you are. Do the intro.
Thank you, thank you. All right, cool. So, welcome everyone to the DevSecCon Bay Area meetup. As I was just saying to everyone in person here, you can't see them all on camera, but there's a huge room full of thousands of people behind me right now. This is a very popular meetup, as you can tell. But before we get into the fun part of the event, I just want to thank the sponsors. So first of all, StepZen is the office space we are hosting this thing out of. They're a super awesome GraphQL company, and basically what they do is if you want to work with APIs and databases and things like that, they will slurp all of that in and give you one really nice GraphQL API that you can then query to make everything work. It's a super nice experience. I use them personally, by the way. Big fan. Also, Teleport is sponsoring the meetup today. They're a great security company, which Ben will talk about shortly. And then I work for Sneak. Sneak is also a sponsor of this meetup. Coincidence? Maybe not. But Sneak is a really cool developer tool you can use for free to help find and fix vulnerabilities in your code, so you should check them out. Now, real quick, I just want to tell you something about DevSecCon if you've never been to one of our meetups before. So DevSecCon is the largest like DevSecOps focused conferences and meetup groups like worldwide. So we have thousands of active members. There's 20 chapters around the world. So they're in places like Sydney, Australia, London, here in the Bay Area, of course, but all over the place. They're just community organized. They're not like ran by any particular company, just random people do them. There's a really cool Discord community you can join. If you're not a part of it, you absolutely should go on. You can get to it by going to that URL there. And we even have a Bay Area specific channel. So if you want to like meet other people in the Bay Area or talk about security stuff, like it's a great place to go. And finally, after the event, we have some other things going on this week as well. One of them, actually this is not happening this week, it's happening in about a month. But we're also hosting a really cool Capture the Flag security challenge thing. So if you're interested in that, you should check it out. And then on Thursday, we're doing an in-person event in San Francisco that we would love for you to attend. It's super free and it's pretty fun. So here it is. Whoops. Oh no.
There it goes.
Ben.
Oh, it's gone.
Was it Chrome, right?
Yeah.
Sorry. Oh God. Sorry, I don't use Macs very much, as you can tell. This is embarrassing. Anyways, thank you.
Oh, no way to go. I think we just minimized it.
Thank you. Okay, so if you would like to come out to our Thursday event, just FYI, you can go register on the website. It's sneak.io/events. It's called Sneak Week San Francisco, and it's basically a full day of security talks and learning about security and hanging out with people. So that's the end of my marketing blurb, but thank you all for coming, and with that, I'm going to hand it over to our featured speaker of the day, Ben. So Ben, take it away, my friend.
Cool. Thank you, Randall. Okay, are we all good there, Randall?
We are.
Okay, great. Well, thanks everyone for coming today. Today I have a talk. I was going between different titles for this, slightly clickbait, but today I'm going to be talking about developer and developers' dirty secrets. And, talking of secrets, I like to say Nano is my favorite text editor. Sorry, the Vim and the Emacs people. But while this is a secret of mine, this isn't the focus of today's secrets talk. I'm going to be talking about more important secrets. And I found this video online when I was trying to find a computer vault to represent secrets in a vault. And I guess you can purchase this if you have a CRT. I also like that you can lock the keyboard away so no one steals it. But we're going to talk about secrets have many different types. So there's like APIs, which can have their own keys and secrets. Shared passwords are another form of secret that we commonly see. GCP secrets, same as AWS credentials, database passwords. SSH, public and private keys. You may think that these are tied to the individual, but they can often be shared within an organization as well, which can cause other issues. And AWS secret access keys, same as GCP. Another interesting one, as I sort of was exploring this topic, is dev tools. So your CI/CD system, your exception tracker, Sneak probably is a dev tool that you might integrate into your applications. And Git Guardian, they actually have this report. Git Guardian is a tool for helping find secrets in your infrastructure. They had a state of secrets that they publish yearly. And they found 6 million secrets in 2021. So obviously lots of secrets, and they try to stop people pushing secrets earlier. And if these categories, they sort of come down here. What I found surprising for this was 21% was around data storage. And I think we were chatting in the data storage spaces. There's still these problems with secrets for all these different types. So others, the large category, and it kind of goes down, cloud provider next. Sort of, nothing too surprising in all these secrets being leaked in the scale. And I think another interesting sort of topic from this talk is they also talk about like secrets in places that you may not think they're going to be. You may have a env file that's encrypted. You may think all your secrets are sort of secure, but they also found that there's a whole ton of secrets also in Docker Hub. And what happens is people create their applications, you create like a demo environment, you're sort of programming, you're working on a project. You might commit a secret in your container, and then that might be at different layers, and you're publishing a Docker image, but within that Docker image, you may have accidentally forgot that you included some sort of secret API key. And this kind of shows that like, even if you're doing your best practices, you can always sort of forget and quite easily publicly publish secrets. And this is from Sneak's report on container-related security incidents. There's two interesting. Actually, do you mind grabbing the blind there? Let's close the blind. So there's a couple of interesting things with the Sneak report. Along with like secret exposure, it also sort of shows that the containers and images that people are publishing also have like overly permissive pod and container configurations. And this can lead to multiple problems. So not only do people get access to the container image, but they pivot and escalate into other parts of the system. And for people who are running Kubernetes, there's potential that they might be using namespace as a security boundary, but it may not be that strong. And I'm going to be talking about this human error and pivot that we sort of see. And so a bit about myself, before I go into Teleport, I previously ran these two companies, and we ran a range of developer tools, one called Redis to Go, which was a NoSQL database service, and Airbrake, which is an exception tracking tool. And we would see this, both tools probably had over 100,000 developers using them. A lot of them free developers that would set up a 5 megabyte Redis instance to get going. And all the time we'd see our API keys in GitHub. This isn't for Redis to Go, but you'd often would see this is what would happen for that password. So that you set up Redis, you just set up a password. Redis actually wasn't really designed to be put on the public internet. Salvatore, the great Sicilian who made it, was very adamant that you shouldn't. He actually held off putting TLS on it so people wouldn't put it on the internet, although people would put various proxies. And people would just set like a very simple password. And this gets committed. And you might wonder, like, Redis is a NoSQL database, then how bad can things get? Which kind of brings me to my next tool that I worked on, was an exception tracker. And one thing that you may or may not know about exception trackers are these tools which developers use to capture information about exceptions that happen in their code. And this is an example I found online of this guy wrote a very verbose logging, and in this error message here, which is sort of, you can see like this stack trace, there's in these like three sort of strings here, you see like MySQL password, localhost. Then the next thing is the username, and the third thing is the password for the MySQL database. And you might say, okay, well, maybe his MySQL was only in the private internet. How bad can it get? And this happened in August. I would say $6 million bad. And before I go too deep into this was for Sentry, which is another open source tool. This hack, there's no indication that Sentry or its infrastructure were compromised, and also saying that Sentry is not secure. But what happened is, as the developers of this Solana wallet created public and private keys, there was some sort of bug that they also sent the private keys to the Sentry instance, and someone got access to the Sentry instance, found all of the private keys, and was able to drain all of the wallets to the value of $6 million. And there's various tools that exception trackers have included. This was a PR added after this, and you can see that they have sort of server-side filtering to sort of dump and not take secrets in. You start with password, secrets, password token, API key, you sort of keep on going. And after this, they added private key and private underscore key to make sure that just by default, that tool doesn't include those credentials. And I think what's sort of interesting about this is, Sentry wasn't vulnerable to any security issues. Someone could have left this server instance open. It could have been an ex-employee. It could be a range of things. And it could have been, was it just a human error? And the interesting thing about human error is, there's like lots of responsibility for humans to take care of. For anyone who's used AWS or GCP, many of the cloud providers talk about your shared responsibility model. AWS say, I think this is a bit unfair because it looks like it's 50-50. Amazon does like all of this. You do the other half. But I would say it's more like 10-90. Amazon's responsible for securing the cloud, so they will make sure that the data centers are secure, people aren't going to go and plug into your server. And you're responsible for everything from encryption, IAM, VPCs, firewall configurations. It's a lot of things, and you can easily sort of shoot yourself in the foot as a person setting it up. And one thing that we see a lot is someone makes a small error, someone gets access to some sort of credentials or a secret, and then they pivot into a higher sort of escalated role. And Verizon actually did a report on various leads to sort of attacks that happened the last year. And they said that these 4 main paths, primarily credentials, was like the leading error that people would then have a human error, pivot, and get access to the infrastructure. Phishing's up there, and I guess exploit vulnerabilities are not executed as much. It's more likely to be credentials or phishing as sort of attacks into people's infrastructure. And this sort of goes back to the other guidelines around how do people get access to infrastructure. It's the same thing. People aren't necessarily exploiting vulnerabilities in servers and applications. They're picking the easier method of just getting some stolen credentials, whether it's through phishing or brute force. They can get access to people's infrastructure. And I might as well make some. Anyone want to guess what this diagram is?
Dependency.
Could be a dependency. Oh, it is a dependency. I mean, it's kind of dependency. This diagram is the 2,200 microservices that Uber uses to run Uber.
Jeez.
And their dependencies and connectivity between all of them, which is a lot of microservices to run. And this kind of brings to my next point, and when we're talking about the shared responsibility, you're managing 2,200 microservices. It's a lot. How do you manage all of this complexity? Obviously, it has to be automated. No human could secure all of those services. And that's why we've seen the rise of, infrastructure as code, Kubernetes, policy as code, other cool tools to help automate these services. But there's also another interesting thing that happens, and we see this a lot, is the scale of infrastructure and people. I pulled this from LinkedIn's Insight tool about the Uber organization. Uber has 6,100 employees, which also surprised me, and is up 30% from last year, but only 5% of the headcount. So I don't know where the other 95, maybe it's drivers. It's a lot of engineers coming and going, and so the median tenure is also 3.2 years. So that means every day there's multiple people being hired, multiple people leaving, being fired. And so a lot of complexity on the human aspect as well. So you're thinking, where am I going to go with this? There's lots of things happening, large microservices, large teams. And we saw lots of these problems at Teleport, which is where I work now. And Teleport, what are the problems? So we'd see like, how do you add and remove hundreds of people in your organization to your infrastructure? You have multiple systems and different tools. You might have the data science team, you might have the BI programming, you might have the ops, the infrastructure. There's all these different tools and teams and infrastructure they need to access to. And this is one I personally saw a lot. I used to work at a large hosting provider that was popular before it got destroyed by AWS. And IT would often bring in all these tools to stop people doing certain things. And most engineers and people on the team would always find a backdoor around them. And so we saw if IT or security didn't make it like the secure way, the easy way, people would always find a backdoor. And so one example is they'd put like endpoint management, but then everyone would just do development on like virtual machines. So it was a much easier way of getting your job done. And another thing we see a lot is like people just don't enforce security best practices. And actually saw a stat last week that there's 800,000 Postgres instances on the internet, which is a lot. And only 40% of them have TLS on them. And so even though it's a best practice, people aren't even providing sort of the best practices. So Teleport is a open source solution for infrastructure access. Here's kind of like the GitHub for us. We call it an access plane. It's a tool for modern infrastructure access. It started off providing access to servers, and as we sort of have grown and worked with our customers and our community, we've added like Kubernetes, databases, applications, and desktops. One thing that's sort of unique about Teleport is it's secretless and passwordless, and it's based on certificates. I'll sort of go into a bit more and explain like what this is. And we can also do things such as provide just-in-time management. And I think from an operational perspective, it's one central thing that you manage as opposed to you have this one gateway which you can control access to all of those thousands of microservices or the thousands of people that you have. And so going back to like the Uber example, just to note, Uber is not a customer. It's just a good example of large organization. They can take their 6,000 employees, add a tool like Teleport to issue short-lived certificates to get access to the infrastructure. For people who are new to certificates, in the world of access, we're pretty used to certificates for, let's say, like TLS, a browser certificate. Let's Encrypt made it very easy to get TLS certificates, but you can also use certificates for accessing databases. You can use certificates for SSH, certificates for Kubernetes. And one thing that's sort of unique is you have, if I go through this diagram here, you can see there's like some public key cryptography. In the subject, you can sort of bake in key traits. And one of the most unique things about certificates make them very useful is you can provide short-lived issuing and self-expiration. And so it's very easy to issue new certificates, and they just automatically expire over a short period of time. And I'll sort of go through the demo, sort of the example. So we sort of say like helps make, oh, I have a question.
So take the example of the Uber. A company's got a large number of engineering employees, people who are moving in and out. And let's take GCP or AWS. You have one of their API keys.
Yeah.
A departing employee has. He goes out. How do you prevent that person from accessing that infrastructure through programmatically, right? He doesn't have a login. He can, because he's got the keys. Unless those keys are revoked, the employee or ex-employee now has still access. The solution which Teleport has, does that help address that use case where you can go and get rid of the key or at least block the key in some manner?
Yeah, we have a solution for AWS specifically. I think managing AWS IAM it's like a whole topic in itself. I think my one recommendation is always using like SSO for AWS, and then you profile support. So you just make sure that developers never use like long-lived credentials from AWS, and you can do that part of the platform. Teleport can also help assume roles. Also for AWS, when you assume a role, it creates a whole bunch of other alerts that you can monitor externally, like whatever their monitoring tool is. And so I think you like turn off the root account, make sure SSO is turned on, and that will like help you a lot. But there's still a possibility, depending upon what privileges you give them, that they may create like a very long token for one service. And then it's a case of just keeping an eye on which user created those tokens and rotating them. But I can like show you a bit actually as I go through this. So we say like, we make the secure way the easy way. So this is so like most engineers start the day like this. I have debug mode on, and what's happening here, I have like a redirection into my cluster, and now I have access to my range of hosts here, so I can just Ubuntu it, to take the Redis example, and then I'm SSH'd in, which is a pretty standard flow here. I have access to htop. Let me exit this. Oh, can't type today. And then you can also use Teleport for like your Kubernetes, your databases, and then it helps like consolidate all of your access. Let me see if there's any other. You can have apps. We have an example of some AWS accounts, and so you can use it for protecting a range of things that you have behind your infrastructure. That's sort of like the developer experience. It sort of like very much gets out of your way. You can just keep the terminal and the command line for getting your job done. For administrators and also other people, we have a kind of a admin panel and a control in which you can review what happened. And there's actually some cool features that we have in here. If we take this session recording, you can like play back exactly what happened on those sessions. You can also share sessions with other people through one central place. You can see my bad typing here again. And what's cool is this is like a full recording of that session. It's not a video. And here we talked about AWS. Actually, I don't know if I have a role configured here, but you can share AWS roles within Teleport. So let's say you just wanted to provide someone like a CloudWatch, or if you wanted like an EC2 read, you could use Teleport as their tool for like a wider team who aren't necessarily in the ops infrastructure space. And then we have like full database support. All of these you sort of connect just using your command line tools or your GUI tools. And the same for service.
Do the certificate rotate?
Yes. So if I...
So it does auto rotation?
So you see I have the certificate here. Like it's valid for 12 hours, which you can configure. As like an admin, you can also like rotate the full CA as well as like kind of a precaution. I think it's CA.
And that's per user base, right? The certificate.
Yeah, and that's like tied in and baked to the identity. I've not rotated my certs, and actually I think on the background it rotates every 12 hours, okay. 24 hours anyway as well. There's some interesting aspects around certificate authorities for infrastructure access, which differs from like PKI infrastructure.
Okay.
You can't have chaining or child authorities for like infrastructure or like SSH.
Yeah,
it's only the first type.
Your chart was slightly different. Yeah, okay.
So let me come back to my deck. And I know like a lot happened there in the demo, so we kind of say these like the essential elements of infrastructure access, like connectivity, just to make sure that you can connect all these instances. You know, you might have in multiple like VPCs or jumps, you want to like make that a very smooth experience. The authentication, that was such a flash because I was already authenticated with GitHub, and so I just logged in with GitHub. Since I was already logged in, it just gave me access. The authorization part is saying, hey, I'm Ben, what role do I have, which service can I access? And then we do this through sort of labeling and tags. And then last up, like auditing, knowing who accessed which infrastructure when, and if you need to, you can go back and see the audit log and perform whatever actions you need, which is also very helpful if you're doing like SOC compliance or FedRAMP or in a highly compliant, you have other compliance regimes. And this is like an infrastructure diagram I pulled up our marketing site to sort of show like a better understanding. So there is like a proxy that you run. You also run like a auth server, which has the certificate authority. The certificate authority is sort of like there, it does its job, but you don't necessarily have to do much to it for it to run. The wheels are attached to the car, as it were. And then you link to identity provider. So what do you do about the other secrets that don't fit into this? I picked a few other like open source. Actually, I could talk about this a little bit. So you will often find that in your whole realm of like infrastructure, there might be things that maybe you can't, like maybe you still have a shared password, maybe there's other options. Most of the time you can likely upgrade it to a better version. For let's say Postgres and MySQL, you should definitely see if you can either use like a self-signed certificate. Other tools like use SSO or use like another provider to get access to them. And there's a few other like open source projects here that I've learned about recently that are pretty cool. AWS Vault, this is from 99 Designs. This is a cool tool which is unrelated to Teleport, but it helps developers store their AWS credentials in their keychain, and so it's never on disk. And this sort of solves the problem if, let's say someone gives you malware on your device. There's many tools actively looking for like AWS credentials because crypto miners like to take them, put them in, and then like fire up some crypto, waste your account. So that's a cool tool. That's an open source one. Another one, SOPs. This is a tool from Mozilla. It's a great tool for distributing secrets. It's actually pretty cool the way in which it encrypts it. The value is encrypted, but not the key. And this also fixes the bootstrapping of trust problem for AWS GCP. There's a great video about SOPs. And my third tool, this is not really an open source tool, but semi-related. GitHub came out with OpenID Connect for GitHub Actions. And this is great because it has like no cloud secrets, authentication and authorization built in, and it rotates credentials. And we have actually a tool in Teleport called Machine ID. It does the same thing. We also have like a GitHub Actions as another open source solution for especially these CI/CD workloads. I think we saw the SolarWinds hack was a compromise of their build system. I think a lot more attackers are seeing these like other build infrastructure as potential like weak bellies of getting access to people's systems. And actually Randall says he has a book club, which I didn't know, but here's some book recommendations. Securing DevOps. This is from Julian, who wrote SOPs. Definitely, this is a great book. Hacking Kubernetes from Andrew Martin, especially as we sort of go to like everyone goes to Kubernetes. There's also like defaults that people don't necessarily do very well. Andrew wrote a great book. We have a book coming out, Identity Native Infrastructure Access Management. It's a bit of a mouthful, but we have the first 2 chapters that are available now. And I also have a podcast called Access Control. I talk to people. It's like practical security advice for startups. So if anyone's interested in being a guest, I'm always looking for people. And thank you. And I have time for questions.
So we're also seeing this area of, it's called identity access and governance. So there are tools which are coming, integrating all the 3 concepts together. So the core case of where employees come and go regularly.
Yeah.
How do you manage identity, map it to the credential which is access, and then provide governance which is reporting regulatory. So how do you ensure all of that is a continuous process and automate that?
I would say Teleport would probably cover a lot of the examples. So I didn't dive into it too much, but you saw like I SSH in as Ubuntu, which is like the shared user. That in the audit log, that Ubuntu is like tied to me logging in as Ubuntu, which sort of solves that sort of problem of who did what actions. And then we rely upon like the SSO providers to have groups which map to our RBAC. So let's say you use Okta, you'd have a operations team. The operations team would link to certain roles. One thing that we've seen more and more though with our like customers is even within their ops team, they look for more controls because it's easy to compromise one ops person. And we actually have a tool, access request. So you have to like request access from like your manager, another teammate, kind of like a PR for infrastructure access. But that also creates control, which can turn into like a
So
SOC.
typically you will have kind of a role-based access.
Yeah.
And if a person changes roles in a company or leaves the company, you need to shift the credentials out.
Yeah, so that would be kind of like through your Okta,
Yeah.
but then because the certificates are only valid for like 8 hours, you could make it shorter, at least for that like one period a day they do the transition. When they log in the next day, it would just put in that Okta group, which would map to their RBAC.
But would not Okta just provide identity access management? It doesn't provide the last part.
No, so that would be where you'd like
You
integrate
are
with a tool like
providing it,
Teleport.
right?
Yeah.
I have a question about the labeling. So it's nice how you had everything labeled in there. Like I saw like a Jenkins instance, for example, and some other things that were labeled. Is that like labeling that is specific to Teleport, or is that pulled in from like AWS tags on the infrastructure or like some other
Yes, so
location?
some of these are like dynamic tags. So like uptime is an example, but we do pull in native AWS tags, and they have this prefix here. And so you see this is, we've recently done an exercise because our costs have gone increased. So we're like, which department has which instance? And so this is why we have like the accounting tags like DevRel. So you can pull these in and then use your like AWS tags without having to do separate tagging.
Got it. So depending on so if you're using AWS, you can pull those in. You can also probably custom label them, I'm guessing.
Yeah, you can send them in. And then they can also be like static or dynamic.
Yeah, gotcha.
And then our RBAC is YAML based. Try and see if I could, maybe this one. And so you see like, it's also which users, which databases you link to which instances. And then you can like consolidate it all in one kind of place.
So here's the question. You are using something like Okta for single sign-on. So you have like Okta managing your identities in one big like database, let's say. And then you also have like roles in there that are tied. So you have like administrators, developers, whatever. Can you also tie that in here and say like, hey, we want to set something up so all of our engineers get access to all of our things tagged to like, you know, AWS / development or something on that.
Yeah.
Cool.
So I'm just choking a bit here. Let me create a new connector. Basically, it's like claims to roles. And so you say like,
okay.
What's your claim for OIDC? I think SAML is better. It's not much better.
Would work,
Yeah.
really well, I think.
This one I didn't touch on because this is sort of like our enterprisey feature, but developers can also like build an inventory of servers that they want to request, and so you can like really limit your like who accesses what or make an access request.
Very cool.
Yeah, I have a question about the edge case for the session recordings. Let's say somebody, let's say you have like a data scientist is accessing a database and running some commands that nobody else should be able to see. Is there a way to like disable the whoever has admin to see that recording of that?
Yeah, you can limit the recordings to just like an auditor, and we also work on like data masking too, so to make sure there wasn't like any other secrets leaked or like PII, for example.
Okay, cool.
Other question was with regards to quantum. There is also the concept of a quantum key generator. So
Oh yeah, quantum resilient algorithms.
Dynamically, so are you looking at incorporating that as well into your architecture?
So OpenSSH, which we do talk like OpenSSH as well. I think they did pick one, and I think the NIST recently did pick their like top algorithms. We haven't gone that deep into it yet, but likely we will just whatever like the NIST recommended.
Well, one is generating quantum keys, but then how do you exchange quantum keys? I think another issue with quantum is you can't securely exchange keys. I think there's a distance limitation to quantum.
I'm not too familiar with the.
Because there are two things. One is
The key creation.
quantum key, and the other is the crypto keys, right?
Yeah.
So the two things. I don't know if there is. Are you seeing any trend towards shift towards those instead of the traditional way of generating keys?
I was just gonna comment maybe slightly. I don't know if this makes a huge difference, but like generally when you're trying to securely exchange the keys over public channels, you basically like have to use like public key crypto since you can't really rely on symmetrical unless you have like a shared party like in person or something. And then depending on the type of like algorithm you like, if you're using RSA, that is potentially something that would be like broken with like sufficiently large quantum computing resources since it's reliant upon prime numbers or whatever. But then I believe there's other ones like Curve 25509 or something, which I believe is like more resilient. And so there's these new NIST recommended algorithms for both public key crypto and which is asymmetrical and symmetrical crypto. And so I think hypothetically what you would do is you would use one of those for the public key exchange. So that way you would exchange it over public channels with someone over the internet and then send through whatever your properly generated quantum key is using whatever the symmetrical algorithm is. It would be for the fast exchange going forward. But you'd still use that same flow, public key for the channels and then exchange a symmetric key over those public key channels.
Yeah, we also have a Fips mode that you can run because most of our customers, it's like an open source binary, people can run them, but we also have one for who doing FedRAMP certification or there's, and for our Fips mode, there's like borrowing crypto from Google, which we compile it in, and there's like certain flags that like turns off certain features, especially for like government organizations that we use, but it's not always necessarily like stronger cryptography, it's just whatever the NIST is recommended for government organizations.
Cool. Well, thank you, Ben.
Thanks, everyone. I have a last pitch too. We also have our meetup or like our user conference in November 9th in San Francisco. And it's normally $200, but I have a free code, Ben VIP. So this will be at the SF Mint, and there'll be many. We think we have like 14 speakers from Teleport talking, and a whole bunch of different interesting use cases from self-driving trucks to like lots of crypto, lots of like hyperscalers, people who sort of like deployed and run our software. So some interesting like DevSecOps crowd too.
Is that case sensitive, that coupon code?
I don't know. I probably should have added 2022. I know if it gets leaked.
You can try both.
Awesome. Well, Ben, thank you so much. I'm going to use that code and steal a free ticket to your thing. So.
Okay, great. I know where it came from.
And everyone tuning in for the live stream, thank you, and we will see you next time.